Hi everyone, thanks for watching my YouTube contents. I'm Sang Kim. In this video, I would like to help you understand about exponential distribution before covering parametric survivor analysis. The characteristics of exponential distribution is like this. The exponential distribution is used to model data with a constant failure rate. And the higher the hazard, the smaller the expected survival time. And exponential distribution is a specific distribution from Weibull distribution. So let's say the cumulative distribution for Weibull is like it has this formula, and when beta equals 1 and gamma equals 0, then it has standard exponential distribution. So this is typical expression about cumulative exponential distribution. So let's say we can pronounce the eta or eta. This is a scale parameter. So typically we use 1 over eta equals lambda. And in Excel, we can use expon.dist function. And we can specify time variable and lambda. And for cumulative density function, specify true option. And this is exponential CDF. As you can see, when eta is smaller, then it has steeper curvature like this. And if you consider derivative form of cumulative density function, then you can get PDF. The PDF form of exponential distribution is like this. So as you can see, again, eta is a scale parameter. In Excel, you can use expon.dist function with the first option. Then it shows different PDF by different eta. So smaller eta has got a very steeper curve like this compared to other eta value. And as I mentioned, I'm going to use exponential distribution for survivor analysis in the coming YouTube contents. So let's think about how to use exponential distribution for hazard function. So this cumulative function, this is a cumulative function for exponential distribution, and 1 minus ft is actually survivor time in survivor analysis, and it can be written as like this form, right? And hazard of t equals ft over survivor time, and if you divide by this one by st, this one, then you can get 1 over eta. So again, I mentioned that 1 over eta equals lambda. So lambda is actually hazard function. And if you consider cumulative hazard, then you can you can use integral from 0 to time t, 1 over eta. So you can get 1 over eta is actually constant. So if you use integral from 0 to t, actually it has 1. So it means the value of this one is actually 1. T. So t times 1 over eta is actually cumulative hazard function. And typically we use actually likelihood function to estimate lambda. So this is formula for likelihood function again. So we consider likelihood for each time. Then if you multiply by all different time, then you can get this formula. All right. Again, and typically we also use log likelihood function. So if you take a logarithm of likelihood function, then you can get this one. And also, if you study statistical inference, then you will learn how to actually is same as 1 over average, 1 over mean. So lambda is actually equal to n over sum of ti, right? So, all right. So let me show you how to get how to estimate lambda of exponential distribution in Excel. Again, so in PowerPoint, I showed you how to get this cumulative distribution. So again, if you use exponential expon.dist function, then you can get CDF for exponential distribution. And if you specify first option in expon.dist function, you can get a PDF of exponential distribution. And I showed you how to get how PDF is different based on different eta value. So let me use again ovariant data, right? So in this video, let's only focus on time data. In this video, I'm not going to consider stat or independent variables, right? Again, as I mentioned, lambda can be calculated by count of FU time and over sum of FU time, right? Then let's get average of time. All right. Again, if you take 1 over lambda, then it actually takes same value of average of time. Okay. So I hope you clearly understand the relationship between lambda and average of time. And again, next, let's get lambda from log likelihood function. So log likelihood can be calculated by using this formula. So count of time variable times log of this one lambda, this value, negative lambda times sum of every time, right? So let's initially set lambda from considering this lambda. So let's say 0.05, something like that, right? So we want to find optimal lambda to maximize this log likelihood, right? Then go to data and click solver. Okay. We want to maximize this log likelihood by changing this lambda value, right? And uncheck this box and click solve. Okay, I think it should be more similar to this one because it actually doesn't converge if you initially set if you do not set lambda, initial value lambda as close to actual lambda, I think, but it's okay in our program. So let's click again. Okay. So if you use our program, the Newton-Raphson algorithm is appropriate to find this lambda, but in Excel, actually, the only option we can use to find lambda is actually solver. Solver use actually GRG nonlinear method. Okay. So again, by using solver, I found optimal lambda, which is same as this one. Okay. Right. This is how to find optimal lambda for time data. Right. right? So I hope it was useful for you to understand how to use exponential distribution to find optimal lambda in Excel. Please click like and subscribe if it was useful for you. Thank you.